let's go through another. So we use the graphical method, which, as I said, we're not going to use, but I think it helps to go through it so we can see how that relates to something called sensitivity analysis we deal with next week. But what we are going to use a great deal is we're going to use Excel Solver. We saw it a little bit last week, but I said, hey, don't worry about it. Well, this week we'll worry about it. So the homework that you'll be getting tonight for next week will be you solving, setting these up in Excel and solving these linear programs. So what I'd like to do step by step, and I'll go as fast as or as slow as you would like, let's solve the space ray and zapper problem in Excel. So pull up Excel if you would. And I put on the board the model that we have, and this is the model that we said, hey, we're deciding dozens of space rays, dozens of zappers, maximize 8x1 plus 5x2, and then all of the constraints. Well, we need to tell Excel about each of those. So I'm going to go into C1, and I'm going to type in space rays, or SRS. And in D1, I'm going to type in zappers. And this is just labeling purposes. So make it as pretty or as ugly as you like. And then in C2 and D2, I'm just going to pre-fill it with 1 and 1, just to get us started. So we're going to assume at the beginning of this that we're making 1 dozen space rays and 1 dozen zappers. Okay. And when I set this up and when I did it on paper, I tried to keep all of my x1s and my x2s in alignment. And the reason for that is that's how they are in Excel. Okay, all the x1 coefficients are going to be in one column, and all the x2 coefficients are going to be in another. So it makes sense to kind of do that when you do it on the board. So we are going to, I'm going to put a label here, max, for maximize. And what I want to put in to C4 and D4 are the coefficients in my objective function. So those are 8 and 5 respectively. Okay, so 8 goes into C5 or C4, and 5 goes into D4. And I'm just going to center everything in these columns now just to make it nice. Now last time we didn't use sum product. Did we use sum product? No? Okay. If I want to figure out profit, what would I do? What would the math I'd do be? I'd multiply 1 times 8 plus 1 times 5. Right now it would give me 13. I could do that in Excel, and I think we did it the long way last time, and I'm going to do it real quick, but don't bother. I mean, you don't have to copy. Equals C2 times C4 plus D2 times D4. And that works. I get 13. Okay? C2 times C4 plus D2 times D4. But if I had, I don't know, 4 of these or 5 of these, it becomes a long, unwieldy expression. Well, there's a function in Excel that we're going to use a great deal. So I'm going to delete that formula I just put in, and I'm going to show you a better way. There's a function in Excel called sum product, because it sums, adds, and products multiplies. Okay? So I'm going to put an equal sign in there, and then I'm going to type sum product, no spaces, SUM product, and open parentheses. It's looking for arrays, and we give it 2 arrays. Arrays are ranges. I'm going to give it the range from C2 to D2 and the range from C4 to D4. And what it'll do is it'll multiply this times this plus this times this. If I had 3 things like that, it would be C2 through E2 and 4 through E4. If I had 10, it would go to L out there, okay? But it's easy. So I'm going to type in sum product, open parenthesis, C2 colon D2. I know many of you are familiar with Excel, but if you're not, the colon means through, right? It means like a range. It says start in C2 and end in D2. So you notice when I put the colon there, it highlighted both of those, the range. If I'd have put E2 in there, it would have highlighted this additional stuff. Comma, no space. The second range I want to give it is C4 through D4. And then I want to end the parentheses. Okay, so it's going to multiply 1 times 8 plus 1 times 5. I hit enter, and I still should get 13 in there. Do you guys get 13 in there? All right. So that is my profit. Right there, that is my profit. If I want to label it as such, this is my profit. Hopefully it's green. So all I put in here is my space raise, that, and my decision variables and my objective function. I'm going to come down another row, and I'm going to put ST out there in A6, just subject to. And once again, I'm going to concentrate on my coefficients. But I'm going to put in the B, I'm going to label these. So I'm going to say plastic. And what is the coefficients for the plastic constraint? 2 and 1 respectively, yes? So 2 and 1. Now if I want to figure out how much plastic I'm using, what math would I do? I would say C2 times C6 plus D2 times D6. But we just learned a function that can do that for us. What was the function? Sum product. Okay, so I would sum product C2 through D2, C6 through D6. But I don't want to retype that again, right? Because I like to use copy and paste where I can. So let's try it. It's not going to work, but let's try it. Let's go up to E4, copy it, Control C if that's how you copy or copy, and then go down to E6 and paste it. And it pasted in there, but alas, we have an issue. If you'll notice, I'm going to double click on that just so I can go in the edit mode and see what's in there. It says sum product C4 through D4, C6 through D6. As you may know, what Excel does is it uses relative addressing. So if I copy a formula down 2 rows, it adjusts all the cell references down 2 rows. If I copy it over a column, it's going to adjust all the cell references over a column, which usually is nice. It usually saves me keystrokes, saves me time, which saves me money. So usually that's good. However, in this case, I don't want part of this equation to change no matter where I copy it. I always want to refer to what in this sum. Okay. This part I want to make static. I don't want it to use relative addressing. Do you guys know how to do that? You guys know how to do that. What do I? We use absolute referencing, and what is the symbol we put in front of it to get that? We use the $sign. Now, instead of putting the $sign in front of both the C and the 2 and the D and the 2, there's a toggle switch in Excel that we're going to use. I'm going to highlight C2 through D2. I missed the 2 there. Missed it again. Highlight C2 through D2. And the toggle switch is F4. Hit the F4 function key on your device. Now, if you have a Mac, does anyone have a Mac? You do? Right now? That's not a Mac, is it? Dustin? Oh, okay. Oh, okay. Were you able to do F4?
Yeah.
Okay, because in the Mac it's like Apple button, do a spin and then hit, I don't know, it's crazy. It's like a, yeah, you can Google it and find out. I can't remember what it is, but it involves 3 buttons, I think, okay? So Dustin, what you might have to do is just manually hard code in the dollar sign, okay, for now, until you figure out what the F code is, but you can find it. And I'm gonna hit enter. Now it doesn't change anything in that formula, but if I copy that down, so let's copy it down to E6 again. And you notice it used absolute reference for C2, D2, but it did change the C6 to D6, which I wanted it to do, right? Because I want to reference the class. You guys with me? Stop if you have questions. I mean, you're not, this is what this class is for. So you're going to struggle with this aspect. Okay. What did we say about plastic? It has to be less than or equal to 1,000. So I'm going to put less than or equal to in F6 and 1,000 in G6. I go down here to my hours, and looks like my coefficients are 3, 4. I'm going to copy that down. And this is great, right? Now that I copy it down, hey, kept my C2 to D2 right, same, which is what I wanted. Now it's referencing C7 to D7. So that cell is representing the number of minutes I use. And that has to be less than or equal to 2400. So the next one is marketing production. It's not listed here, but we assume it's implied 1 for the X1, X2. So 1 and 1. Copy that down again. Has to be less than or equal to 700. And the last one, marketing 1. What's the coefficient here? -1. And by this point, Excel realizes I'm copying down every time, so it says, hey, let me do it for you. I notice you've done it 3 times now. And has to be less than or equal to 350. We haven't solved this. Any questions? You guys, anyone, is everyone here? If you're not, raise your hand, I'll come look at your screen. Okay, we haven't solved this. All we've done is taken it from the paper or the board model and put it in Excel. And I could do, remember we did the first class, we did trial and error. I could try trial and error. I could change, and make sure when you do this, everything's changing. I could say, what if I make 100 dozen space rays and 100 dozen zappers? Well, that's $1,300. I'm only using 300 pounds of my plastic, 700 hours, 200 dozen I'm making total, and I'm okay. And I say, well, geez, I could do a lot better. So maybe try 300 and 300, making 3,900, still adhering to everything. Well, I could do better. I don't know, try 500 and 500. Whoa, I'm making 6,500, which is nice, but I'm using 500 pounds more plastic than I have. I'm using more hours than I have. So there's a combination there. There is one optimal solution that adheres to all these constraints, yet maximizes the 6,500, or that maximizes this profit. That's what I want to find. Okay, that's what I'm looking for. I'm looking for the best way, the optimal solution. Luckily for us, I don't have to do trial and error. I'm human. It would take me a long time to do that. Let's use our friend Solver. So we need to tell Solver about those 3 things. So go to your data tab. Does everyone have Solver? Because last week we installed it, but some people didn't have their laptop with them, so is everyone able to install that? Okay. So go to data, and let's invoke Solver by clicking on Solver. Okay, first things first. I need to tell it what one cell represents my objective here. If I am Galaxy Industry, what one cell represents what I'm trying to maximize or minimize. What one cell? E4. So I'm going to hit this little mini spreadsheet by this input box. I'm going to select E4. And then I'm going to close the window, and it shoves E4 in there for me. Am I maximizing or minimizing E4? I want to make it as big as possible, so max. By changing variable cells. So this is Excel Solver asking me, all right, I'll make that as big as I can, but what will you allow me to change? Or what will you allow me to decide? What will I allow Excel to change or decide? What up here will I allow it to change or decide? C2, D2. So, let's hit the little spreadsheet. Highlight C2 through D2. You notice it puts it in C2 colon D2. I could have typed that in as well, but I don't like to type, I like to click. A little drop down, and now I have that in. So at this point, I've told Excel where my profit is, what I'm trying to maximize, and I've told it about what to change, but I haven't told it about any of the constraints. So if I click Solve, what's the solution? If I haven't told it about any constraints, what's Excel's solution going to be? Make an infinite amount of space frames, infinite amount of zappers, and congratulations, you have an infinite amount of profit. But that's not what we're in. So we need to come down here and say subject to the constraints. Right now I have no constraints. I need to add the constraints. Okay? I'm going to add them one by one, but I'm going to show you how it is really simple to do all in a group. So let's do our plastic constraint. I'm going to click Add. Let's see, I'm going to click Add. And it comes up with this new dialog. And I'm going to say the total plastic used, which is E6. Remember, that's the thing that changes as I change these decision variables. The total plastic I use has to be less than or equal to what value? Be 1,000, but I don't like to hard code it. I like to give it a cell reference. Has to be less than or equal to G6. E6 less than or equal to G6. Click Add. Now it just disappears. That's a terribly inelegant design interface. But alas, that's what Microsoft did. If I click Cancel at this point, which is terrible to do, you think, oh my God, I'm canceling out all this work I've done. It takes me back to this. Okay? Now I have my objective function, this changing variable cells, and I have one constraint. I told Excel about one constraint, plastic constraint. I haven't told it about the other. Let's just solve it now and see what it would be if I only had the plastic constraint. Let's just, for the kicks, let's solve it. So I'm going to select the solving method simplex LP. If yours doesn't have simplex LP, change it to simplex LP. And click Solve. And it says Solver found a solution. All constraints and optimality conditions are satisfied. Click OK to keep solver solution. It says make no space raise and 1,000 zappers. And you'll make $5,000. What's the issue with that? I only used 1,000 pounds of plastic. What's the issue with that? Why isn't that my optimal solution? What does it violate? I'm using 4,000 production minutes. I only have 2,400. And I'm making 1,000 and marketing told me only make 700. Well, the reason Excel did that is why? I didn't tell it about those other 3 constraints. I just told it about that one, yes? So it didn't know about them. Let's go back into Solver and tell it about those other 3 as well. Now I'm going to show you a little shortcut here. Go to Solver. Click Add. Okay, because all of these 3 are less than or equal to, and I designed it so that they're all in the same columns, I can enter this as an array. I can say E7 through E9 on my left-hand side should be less than or equal to G7 through G9, respectively. Because they're all less than or equal to. If I had a greater than in the middle of that, I couldn't have done it. But because I designed it so that they're all less than or equal to, all nice together, I said E7 through 8, E9, I'm sorry, has to be less than or equal to G7 through G9, respectively. And then if I click Add, and then Cancel, you'll see it put it in there, but it's in essence adding 3 constraints at once. Does that make sense? I could have done all 4 at once if I wanted to, but I only did 3 because I wanted to show you. And you don't have to do it that way. I don't care. All right. If I click Solve now, Excel should know about all my constraints, and it should give me the optimal solution. Click Solve. It says Solver found a solution. All constraints and optimality conditions are satisfied. Click Keep Solver Solution. It says if you produce 320 dozen space rays and 360 dozen zappers, you'll make a profit of 4,360. Now, a couple things. Did I adhere to all my constraints? Did I violate any of my constraints? Did I adhere to them all? Yes, I did. Excel knew about them. It picked the points that it knew were feasible. But let's look a little further at this. This is the optimal solution. What is holding me back from making more profit at Galaxy Industries? What is, and the word we use, is what constraints are binding. Meaning, we've pushed them to the limit. Remember that feasible region we graphed up there? Remember the last point we touched? We were using all of something. What are the constraints that are binding here? What are the things that are holding me back? And if I got more of that, I could make more profit. I used 1,000 pounds of plastic. I had 1,000 pounds. I had 2,400 minutes. I used all 2,400 minutes. You can bet your fanny that if I got more plastic, I could make more space rays and zappers and make more money. Let's see. Let's do a what if now. So let's say this goes up to 1,010 pounds. Right now my profit is 4,360. I click Solve. Okay. Now I make 320, 328, 354. My profit went up 34 bucks. Now, how much did that extra 10 pounds of plastic cost? Well, if it costs less than 34 bucks, I'm in business, right? It did. Good. We'll talk about that later. Let's go back to the original formulation. And resolve it. Just click solver, and solve again. Now remember what I said at the beginning of this lecture. I said there was a lot of assumptions that we had to make to use linear programming. And then I said we violate them all in real life. So what the hell good is this? For example, I said we have to assume that we know this with certainty, that we make $8 for every dozen space rays, and we make $5 for every dozen zappers we make. Well, what if this went up to $9? Okay, let's change that 8 to a 9. Okay, and let's resolve. What happened to my solution? And my solution, remember, is how many dozen space rays to make and how many dozen zappers to make. What happened to my solution? It did not change. What happened to my objective function? It increased. But what this is telling me is not only is this a solution if I make $8 per dozen for a dozen space rays, but if I make $9 per dozen for space rays, that's still the right mix to make. So even though we make a big assumption, we violate that assumption, we assume it's 8, it's still what we call a robust solution, because the solution still makes sense in a range of values, right? It still makes sense. Now next week, we're going to talk about something called sensitivity analysis. And we're going to go a little further. We're going to say how sensitive is this solution to changes in the environment. And I'm going to show you how to analyze that, but that's too much for this week. Questions on this? I'm going to ask you guys to do one. Does everyone have a laptop? I'm going to ask you guys before I send you out into the world and have you do your homework this week and then struggle and curse me and all those things. Let's do one together, okay? Or let's try to do one together, okay? So, everyone have their book? If not, please share. I'll give you one of the homework problems. So we'll start our homework together. We'll do an easy one. Let's do 2A on page 101. And here's what I'd like you to do. I'd like you to write it down like this first. Write down the model, write down the math like this. Decision variables, objective function, constraint. And then I would like you to put it in Excel and solve it.